pen mode. Okay, so here we go. So we are going to put some kind of a t-axis and a velocity in meters per second axis. Okay. Now, they are saying that the object was dropped. What if it is dropped? Okay, and they are asking us about the final speed. Okay, we know that an object that is being dropped, that means the initial velocity is equal to, I hope you said, 0. Therefore, you should write somewhere in your solution process v sub x. Actually, it shouldn't be x because we're dropping along a vertical, so we should be saying sub y here, sub y, because we're doing it along the vertical. Okay? So v sub y sub I equals 0, not tomatoes, not kiwis, not potatoes, meters per second, you silly bananas. Okay, and now what in the world is this height business? Well, it's measured in meters. So it would be either an xf or an xi. Well, it was at a height of a certain sort, so maybe that's my xi, you know, is equal to 2.5 meters. It's going to be dropped and reaches the ground. So at the ground, x, why am I using x, silly me? I'm using y. Okay, yf will be equal to 0 meters. Okay, cool so far? What's next? Do I have any time? I don't know. I don't have any times. Do I have some final velocity? Well, duh, that's exactly what they are asking for. Okay, so I would have to put my v sub y sub f is unknown to me. Go so far? I hope you said yes. Okay, good. So here's the deal though. At this point I have this thing here and I have no idea how to go about solving this problem. But then again, let your geometry guide you, either a slope or an area. Those are the two. Well, since they gave me some kind of a displacement here, and if you recall from the other few lectures, you know, in the other videos, delta x is representing the area under a curve or under a line, you know, representing the velocity versus time graph. So let's build our graph of velocity first. I am starting at 0, so I should start right there. And then it's increasing constantly. And then at a certain point, whatever this velocity final here, I have no idea. This vyf, I have no idea what it is equal to. But this vyi, I know for certain is equal to 0. See right there. Okay. So, whether I like it or not, at a certain time t later, whether we like it or not, at a certain time t later, this, you know, which is unknown to us, and for now, we're not going to panic about it, that's okay. We're going to take this here, and we are going to get us an area. You should have thought that the area would have to be equal to the displacement. Well, what's the total displacement here? I hope you answered 2.5 meters. So, my delta x, my delta y here, my delta y is equal to, in this case, final minus initial. According to this, it should be a negative value, but I am talking about the absolute value. But for now, I could write that. That's okay, negative 2.5 meters. I know it does not make sense to have an area that is negative, but we're just talking about the fact that it is a displacement, and I'm doing final minus initial, okay? Things will work out by themselves out. Don't worry about it. Okay, so now I've got this. Well, what am I going to do with this? I have no idea. I need some kind of area, so the area is supposed to be equal, meaning this delta y, which is the area, is equal to half. I love what my system is doing here, okay? So, 1/2 the base, which is the time, and multiplied by the height, which is in this case VF VYF, which I don't have. I have no idea. So VYF times sometime I have this, and I don't have that, and I don't have that. Cool or no cool so far? Okay. So at this point, I have some information about this. But of course, I have other bits of information that I cannot ignore, which is the fact, what did we say the slope of the velocity versus time graph is supposed to be? Acceleration. Okay. But the acceleration here is not any kind of acceleration. It's a specific kind of acceleration. And it is dropped. It is very good. It is the acceleration caused by gravity. But because of the fact that I am defining my frame of reference in such a way that up is positive and the gravitational acceleration is pointing downward, so that means I am going to deal with a slope in this case that is going to be negative. So my acceleration along the y is going to be negative 9.8 meters per square second. Cool or no cool so far? You would say, okay, so how is this going to help me? Of course it's going to help you. We're going to write the equation of the line now. Well, the equation of the line is going to be VYF, which I don't know, equals negative 9.8 meters per square second. And I am multiplying it by time, duh, because that's my, this is in a sense, one of the equations that we've been working, and it's the equation of the line anyway. And then plus some initial velocity, which is 0. Hey, we're making some progress here. Look, 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 guys. I don't have the time. I don't have the VYF, but I do have, the value of this. So let me summarize this a little bit. So I'm going to take this one and write them in the next slide. The problem is, the next slide is actually, I put the solution in there. So I'm going to distract us, and I'll use a different, thingy completely. So, but the problem is, I don't remember what I have here. So I'm old. I'm old, guys. So here we go. I am going to. Oh, great, silly Nadj. Jeez. Okay. So let's say I take these, so I would be able to copy them. Uh-oh, it copied everything. Never mind. I am going to just go ahead to the other slide. So one more time. Oh, geez. Delta y equals half vyt times t. Okay. So whatever. Delta y equals half vyf times t. Am I correct? Not bad, Nadj. And then VYF is going to equal to negative 9.8 meters per square second times t. So VYF is equal to negative 9.8 meters per square second times t. Do we know the value of delta y? You bet your life. What did we say? We said it's supposed to be equal to negative 2.5 meters. Okay. So I could conceivably say, okay, this one is equal to negative 2.5 meters. Okie dokie now. Here's what I'm going to do. I'm going to be wild. Look, I don't have t. I'm going to get rid of it. Watch how I'm going to get rid of it. I am going to do some math wizardry here. I'm going to divide the right side by the right side and the left side by the left side. So I'm going to get negative 2.5 meters divided by VYF equals, and then this here is going to, the t and the t will cancel out. Oh yeah, oh yeah. And then I am going to have 1/2 divided by 9.8, whatever that would be. I'm not going to worry about it for now. So I'm just going to write VYF, and then negative 2 times 9.8, that would be 19.6 meters per square second. If you don't trust me, and always don't trust me, check your calculator. Okay, so I've got this. How am I going to solve this? Well, I hope you learned in your math classes that you could do the cross product. So I'm going to do the cross product. When I do that, look at the beauty. Hey, whoa, 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 yo, bad Nadj. Here we go. Silly Nadj, rather. Okay, negative. So the product of these two is going to give me, look, guys, look, it's going to be cool. VYF squared. And then this is going to be negative times negative, which is positive. Yes. And then meter times meter per square second, that would give me meter squared per square second. And then 2.5 times 9.6. I am not a calculating person. I'm going to rely on my calculator to do that job for me. But what you care about eventually, once you do the multiplication, I hope you thought from a math point of view, you're going to take the square root of everything. So what's the square root of VYF? That would be, VYF squared. So that would be VYF equals, and then the square root of meter squared per second squared, that would be the square root of meter squared is meter, the square root of second is second. Oh yeah, you've got my meter per second as opposed to any other unit. That's the unit for velocity. Now, all I have to do is just do the square root of this. I don't know. I'm going to do it, and I'm going to come back. So, here we go. I pulled my trusty calculator. I have no, I don't say trusty calculator. I entrust only myself. Anyway, so 2.5 times 19.6, hit that. Oh my God, it's 49. Woo-hoo! So, what's the square root? So this is 49. What's the square root of 49? 7. If I want to pay attention to, sig figs, 7.0 meters per second. My friends, I know you may not think this is cool. If you don't, then here's the other possibility. This is the solution process. Draw the situation. In my case, I drew graphs, but in your case, what you could draw here is, for example, a ball, some kind of a ground. You show that this is 2.5 meters, okay? And then, that's a good diagram enough for me. And then the initial velocity is 0. The acceleration is 9.8. So here I must have used, when I did this 50 years ago, I must have done it with the assumption that downward is positive. So probably that's what happened. And then delta y is equal to 2.5. So you could put something like that in this. And then what are the unknowns? The VYF and the delta t. So now, if you recall, I gave you guys a formula to prove. So this is the formula to prove. And when you use that formula, notice that formula does not involve time. So if you're comfortable using yet another formula, that's fine with me. It's in the textbook. It's the third formula beside the two big kahunas that we found. Okay. See, I did not need it in using my own processes. Anyway, and then at that point you substitute. So I substituted for Vyi 0, and then at this point I took the square root of both sides to end up with this, and then I plugged in the 2 times 9.8 times the 2.5. I never forget about my units. And then at that point I ended up with 49 meters squared per second squared. You got that. Thou shalt reflect. How?